artificial intelligence and machine learning. They get used interchangeably, like all the time. Our goal here is to really unpack these concepts, figure out their distinct roles, and honestly reveal how they work together in some pretty fascinating ways. You should walk away with a much clearer picture, ready to spot them out in the wild. We've got some great source material that lays it all out, from the basic definitions to, well, some surprising applications and even a peek at what's next.
Yeah, and it's so important to get these concepts right. They're not just buzzwords anymore. They are fundamentally reshaping, well, everything. Healthcare, finance, you name it. What's really interesting, I think, is just how distinct they are fundamentally, but how powerful they become when you put them together.
Okay, let's unpack this then. We should probably start with artificial intelligence, AI. It often sounds like something straight out of science fiction, doesn't it? But what does it really mean in computer science terms? Our research points to it being essentially the simulation of human cognitive functions by machines. So we're talking about things like reasoning, problem solving, making decisions.
Right, and learning too. Even understanding language, recognizing images, that sort of thing, natural language processing, computer vision, robotics, they all fall under this umbrella. If you look at the bigger picture, AI is really this overarching ambition, to create systems that can mimic human intelligence. It's about designing machines to do tasks that traditionally you'd need a human mind for.
So it's not just simple automation, it's more about thinking and adapting.
Exactly. Adaptability is key. AI systems can adjust to new information, new environments, and autonomy, they can operate with less human intervention. Plus, handling complex tasks. Think about, say, medical diagnosis from scans, or an autonomous car navigating busy streets, or even financial forecasting. These are multifaceted problems.
Okay, that makes sense. It's a broad goal.
It is, and it helps to think about two main types. First, there's narrow AI, or sometimes called weak AI. This is the AI we interact with daily. It's designed for very specific tasks. Think Siri or maybe Netflix recommendations, brilliant at one thing.
Got it, like a specialist.
Precisely. Then you have the concept of general AI, or strong AI. Now, this is still mostly theoretical, hypothetical systems with human-like consciousness, broad cognitive abilities. That's still deep in the research phase. And remember, AI isn't just one single technology. It integrates lots of things. Machine learning is a big one, deep learning, neural networks, even older rule-based systems, all working towards that intelligent behavior.
Okay, so if AI is the big ambition, the brain maybe, where does machine learning ML fit in? Is it just part of AI?
Well,
Our source seems to treat it as a specific component.
That's exactly right. ML is a specialized subset of AI. Its focus is very specific, enabling machines to learn from data without needing explicit programming for every single possibility.
Ah, okay. So less programming every rule, more learning from examples.
Exactly. If AI is the brain, then maybe ML is the learning mechanism within that brain. ML algorithms look for patterns in data, they make predictions, and crucially, they get better over time as they process more data. They learn from experience.
Okay, that learning mechanism idea helps. So how does a machine actually learn? What are the main ways?
Well, there are three main types of machine learning. First up is supervised learning. Think of this like teaching with flashcards, where you have the question and the answer already paired up. The model learns from labeled input data that comes with the correct output. Spam detection is a classic example, right? You feed it emails labeled spam or not spam, and it learns the patterns.
Okay, so it learns from known answers. What about when you don't have the answers?
That brings us to unsupervised learning. Here, the machine gets unlabeled data and has to find the hidden patterns or structures itself, like finding groups of customers with similar buying habits without being told what groups to look for initially. Customer segmentation is a big application here.
So it discovers the structure on its own.
Interesting. And the third type?
That's reinforcement learning. This is more about learning through trial and error, interacting with an environment. The system gets rewards for good actions and penalties for bad ones. Think about how game-playing AIs like AlphaGo learned to master Go. It played against itself millions of times, learning strategies based purely on winning or losing. It's very dynamic.
Wow, okay. Trial and error, like how we learn sometimes.
Pretty much. And you see ML everywhere because of these methods. Personalized recommendations on Netflix or Spotify, that's ML fraud detection in banking, ML again. Even predicting when factory equipment might fail, predictive maintenance, that's often ML working behind the scenes. Okay, this is really where the confusion often creeps in for people, myself included sometimes. Let's nail down these core differences based on our research. How do AI and ML really compare head to head? First, let's talk scope. AI is broad, right? Mimicking human intelligence in a general sense.
Right, whereas ML is much narrower. It's specifically focused on that learning from data aspect. It's a technique within AI.
So AI is the forest,
Hmm.
ML is a specific type of maybe very important tree.
That's a good way to put it. While ML is part of AI, it's a very specific toolset for achieving that data-driven improvement. AI is the bigger vision. ML is one powerful way to enable learning within that vision.
Okay, and that naturally affects their goal then. AI aims to solve complex problems autonomously, act intelligently in varied situations.
Yeah, the goal is broader intelligence. ML's goal is more specific. Improve accuracy on a particular task by learning from the data fed to it, like getting better and better at predicting, say, house prices.
Gotcha. And the techniques reflect this too. AI uses a whole toolkit, ML, yes, but also NLP, computer vision, robotics, expert systems.
While ML primarily relies on statistical models and algorithms, its main job is finding those patterns and making predictions based on them.
What about data dependency? Our sources mention AI can handle all sorts of data, structured, unstructured, like text or images.
Right. AI aims to integrate diverse information. ML models, especially traditional ones, tend to work best with structured or semi-structured data because their focus is on extracting clear patterns from organized information.
Okay. And finally, decision making. AI uses logic, reasoning, even self-correction. It can adapt its strategy.
Whereas ML relies more heavily on the patterns it recognizes and the statistical predictions from the data it learned, it's less about abstract reasoning, more about likelihoods based on past data. But critically, ML is often the engine powering that AI's ability to learn and adapt over time.
So we've teased them apart. Now let's look at how they become so powerful when they work together. Our sources really stress this symbiotic relationship. One key way is that AI systems use ML components. The autonomous vehicle example is perfect. The overall AI makes driving decisions, but it relies heavily on ML models.
To do things like recognize stop signs or pedestrians or lane markings from camera feeds, right? ML does the pattern recognition that feeds the AI's decision process. Yeah, you really can't have advanced AI without these kinds of robust ML components feeding it information and enabling learning. It's like the brain needing continuous input and learning to function intelligently.
And the second way they interact is that ML enhances AI, right? Data scientists are always refining ML models, which makes the overall AI system better.
Absolutely. Think about chatbots. They're AI applications, but they get smarter and more helpful because the underlying ML models learn from thousands, millions of conversations, improving how they understand us and respond.
And this creates that feedback loop you mentioned. AI applications generate data in the real world.
Exactly. And that data gets fed back to train the ML models further, making them better, which in turn improves the AI. It's a cycle.
Though, as you noted, that cycle can also reinforce biases if we're not careful about the data.
That's a huge challenge, definitely. Fairness and bias mitigation are critical areas. But the synergy itself is powerful. Look at the healthcare example our sources give. You might have an AI analyzing patient records, maybe suggesting diagnoses or treatments. That's the broader intelligence. At the same time, you have ML models predicting potential disease outbreaks by learning from historical public health data, finding subtle patterns. The ML predictions inform the AI's analysis. Clear synergy.
Okay, this really brings it home. These aren't just lab concepts. They're out there woven into our lives, into industries. Our sources had some great examples. In healthcare, beyond diagnostics and predictions, AI is enabling things like robotic surgery for incredible precision.
Yeah, and ML is predicting patient readmissions, allowing hospitals to be more proactive.
Then in finance, you mentioned AI chatbots for customer service. And ML is huge for fraud detection, algorithmic trading.
Absolutely. Real-time analysis, spotting anomalies that humans might miss. It's fundamental now.
What about retail? I use visual search sometimes. That feels like AI.
It likely is. AI for visual search. And then ML is working behind the scenes on-demand forecasting, figuring out what you'll want to buy next, and managing inventory super efficiently.
Makes sense. And manufacturing. Predictive maintenance sounds huge.
It is. AI predicting machine failures before they happen saves enormous amounts of money and downtime. And ML helps optimize these incredibly complex global supply chains.
Even environmental conservation is using this tech. That's amazing.
Yeah, AI analyzing satellite images to track deforestation, monitor wildlife populations, and ML models are getting better at predicting natural disasters like hurricanes or wildfires, giving crucial early warnings. So when you connect all these dots, it's clear these aren't niche anymore, they're foundational. ML provides specific learning power that enables these broader AI solutions everywhere.
And it's not stopping there, right? These fields are moving incredibly fast. Our sources pointed to some future trends. What's on the horizon?
Well, one really important area is explainable AI, or XAI. The idea is making AI decisions less of a black box.
So we can understand why the AI made a certain recommendation.
Exactly. Crucial for trust, for compliance, especially in high-stakes fields like medicine or law. Another fascinating trend is federated learning. This allows ML models to train on data stored on local devices, like phones, without the raw data ever leaving the device.
Oh, wow. So learning happens collectively but privately.
Precisely. Big implications for privacy. Then there's the whole growing field of AI ethics, actively working to address bias in models, ensure fairness, make AI accountable. That's becoming central.
As it should be.
And further out, maybe, is quantum ML, combining the power of quantum computing with machine learning. The potential speed and capability there could be transformative for certain problems.
Okay, so it's not just getting more powerful, but hopefully more transparent, private, and ethical too.
That's the goal, or at least the direction many are pushing for. It addresses the tech and the societal impact.
So wrapping this up, what does this all mean for you listening? You've just done this deep dive with us into AI and ML. Hopefully it's clearer now that AI is that big visionary framework for intelligent systems, mimicking human thinking. And ML is the powerful engine inside, the part that learns from data, getting better over time.
They really are symbiotic. They need each other to drive the kind of innovation we're seeing, from everyday conveniences to tackling huge global challenges.
Understanding their differences, but more importantly, how they link up, really helps make sense of the smart technology exploding around us.
Exactly. And understanding that helps you appreciate the incredible potential they hold. So maybe a final thought for you to ponder. The next time you interact with a smart system, maybe it's your phone suggesting the next word or a navigation app rerouting you, or even something more complex, just pause for a second. Ask yourself, am I seeing AI's broad intelligence at work here, or ML's specific data-driven learning? Or, perhaps most likely, is it both, working together in this powerful, fascinating concert?